There we go. Okay, got it. There's
So,
Al too.
your X, the X that I drew is going to be the GPS waypoint, right? And this is
Yep.
a representation of your example. So obviously the orientation for one is going to be that.
Perfect.
And you're saying the orientation for your third one wants to be there.
Right. And then at 2, you could either still be going straight with your original point, you could be all the way turned towards 3, or you could be halfway in between. I mean, those are the first 3 obvious examples, but then you could be, you could be anywhere else as well too, right? I mean, you could come in sort of top down in that, I don't know why you'd want to do that, because then you'd have a crooked path, but you could force it to come in, go all the way around and come down from the top and then come back out again too.
So I think as a user, if you want this behavior, if you want to make a hard left turn for whatever reason, I think what you'll actually do is one will stay the same, and you'll actually have like a third waypoint here. So you'll have one waypoint here. Okay, let me erase some things. So you'll have this.
Yeah.
And this is, I guess 2.
That's if you went straight into that waypoint and continue. Yeah.
And then you'll have 4. So you'll actually define 4 waypoints there, is what I'm thinking. So it's red, green, blue, and then red.
Yeah, that's just, a good point. If you wanted to make a completely hard corner there, you'd have to go with an Ackerman steering. You'd have to go through, back up, and then go ahead, right?
Right. So there'd be a little bit of oscillation between pose 2 and 3.
Right.
But I guess that's what you get for wanting to make a hard left turn.
Yeah, and I guess when I say hard left turn, that's that's really where it starts to become interesting, right? And that's where, so if I back up just a little bit, one of the things, when Al asked the question, one of the things that I had been thinking about is I want it as simple as possible for the person uploading the data into the system, right? So if I have 2 fields, if I just want to know my lat and longs, that's simpler than if I have to provide lat long and then a third column called bearing. It's just a little more complicated for the user to provide that extra value.
Sure.
So if there's reasons why you have to have it, then you have to have it. Because what I would do, can I draw on your screen, or can I?
Go ahead. You can. You can try. I don't know how it'll work.
How to do that?
I won't be offended though.
Go ahead.
Under view options, there's annotate, and then you can draw.
I'll draw on your screen. Because the other thing in my post in Slack, I was saying it depends on how many waypoints you have and how far apart these are too. So I was trying to think about it, what are the parameters that affect this? So if this is 1,000 feet and my rover is only 3 feet, if this is my rover and it's that big, right, relatively speaking,
okay,
and this is 1,000 feet, it's probably a different scenario than if this is my rover and I'm this big and I got, one rover distance before I get to the next point. I've got that's how many waypoints do I provide to the machine is one of the factors, I think. And then the other thought would be if I could provide more waypoints. So now I'm going to provide waypoints. Let's see here. Can I change?
Sure.
Here. If I put green dots, if I put more waypoints on here, I could even go like this and tell it, this is the path I want to take. And if I was recording waypoints from if I go out and drive it manually and record waypoints, this is what I would, I'd probably get something like that. And then I could force it to steer in this case, I don't want to have to provide it. I wouldn't have to provide a bearing for every one of those points because it would be able to figure out that this is, it'd just make a smooth line around there.
Well, okay, so with move base flex, you can actually do that. You can actually give it a path that you've calculated yourself. And a path is a collection of poses. And poses have both position and orientation. So let's say you did record that green dotted line, you'd be able to feed that back into move base flex, and your robot will execute that directly, or as directly as possible.
Right. Yeah.
So I guess my other question is, and tell me if I'm nitpicking on your example too much.
Oh no, that's fine.
But
that's fine.
Why would you want to make a hard left turn? Is it because there's an obstacle here?
Yeah, that was just thinking out loud through what I was just really the only point of doing that hard left turn example was to say, what are the possible orientations going into that corner? Just simple, right? I'm either going to continue to go this way, I'm going to go this way, or I'm going to be halfway turned.
Because let's say I'm going to start a new whiteboard. Okay.
Yeah.
Benny, to answer your question, though, the use case for a hard right turn is in a hay cutting or raking hay scenario.
Yeah, it could be something like that.
It's not like planting corn where you're going to go up and want to come back as close to the previous line. I'm effectively, well, it's just like mowing a lawn, except you've got a 12-foot implement hanging off the side of your tractor.
Sure. So I guess one thing I was going to do to address that is, let's say you have a sensor that you're able to pick up this hay.
But before you go on, quite honestly, you might be overcomplicating it, at least from my perspective. I just want to test driving 2 points, and I want to know what the input, what's the input mechanism to test driving 2 points, whether it's 2 points or 200 points, and if there are options, that's fantastic. But can I just test 2 points is really what I'm trying to do.
Sure. So yeah, to test 2 points, all I would say is the lat long coordinates and then a desired orientation for both of those points.
Yeah. See, I'm going simple, and I'm saying I don't know what the I remember hearing the first time that in Ross east is 0 and north is 1.5, or it's in radians and all that stuff, and so somebody says, hey, so if I look at this picture here and I've got, let's say I know my lat longs, what's the orientation at 0.2? It's 45 degrees to the in Al's example, he just wants to drive from 0.1 to 0.2. It's going to draw a straight line, and Ross could do the math to figure out what that orientation needs to be by the time it gets to 0.2. If you're going to ask me to figure out what's that orientation at 0.2, I'm stuck. I'm going to have to go crack open some serious math and some serious books to figure out what's that orientation at 0.2. But I can tell you what the lat longs are a lot easier. That's kind of where I'm saying I don't want to provide the bearing if I don't have to.
So theoretically, you'd want to define your mission by a lat long and your compass bearing, and then if I were developing the system, I would let the code calculate your compass bearing to
sure.
a quaternion in your map. I would let the computer do that solving, and then put it in Ross compatible oppose, and then execute upon that.
Yeah.
And
yeah.
I'm just curious,
I don't know. Yeah.
Is that something I can test this weekend? I mean, I'm at a really simple sort of, hey, I've got this thing out there and I can send it command velocity statements. Can I move to the next level?
When you said you want to do 2 points, is it okay if the very first point is actually where your robot is at?
Sure,
And then the second point is one that you send?
sure.
Are you familiar with the 2D nav goal in RViz?
Yeah, but is that what we're going to use for navigation?
That's dynamic planning. So it's all very similar. So for example, when you click in RViz and you draw that arrow, you're sending 3 pieces of information. That's all it's doing. You're sending it X, Y, and yaw. So and that's just an action server. So like if you wanted to send in your own X, Y, yaw, MoveBase will take it. It's just sitting there listening. RViz has a little arrow, just makes it a little bit easier.
But as soon after I do one, do 1 point or 2 points, whether it's, 1 or 2, I guess is now up for debate. Then it's okay, how do I cut a 5-acre hayfield? And
Yeah, baby steps.
pointing and clicking, 2D nav goals isn't the way I want to cut a 5-acre hayfield.
Right. So I guess that's what we're talking about right now, is defining a mission. But I guess for your application, Al, or for your step, I would say using RViz and pointing and clicking might be the first step, and then then defining the mission.
Okay, I mean, if that's where we're at, that's where we're at.
Yeah.
I think maybe the answer is that it depends, in terms of should I provide bearing or not. I think it really depends on what the goal of the overall system is. And so that's where I was trying to go, is what are the factors that would influence, do I provide bearing or not provide bearing? And if you want to make it so that you have to provide bearing, I mean, that's fine with me. It doesn't matter to me, but I just was arguing towards simplicity. And if it's basically bearing, to me, is a given in the program. Like if I have point 1 and point 2, and let's just, for the sake of it, let's say that's northwest and it's a 45-degree, it's perfectly northwest. The computer can figure that bearing out for me. So there's no point in me, it's redundant for me to provide it, and it's a potential point of error if I have to provide that point. So in that example, that's why I was saying, yeah, if I don't have to provide it, it's easier and less error prone. But if that falls apart when it gets to be more complicated, or if the standard convention isn't, and I see Jeremy's here, isn't Jeremy working on some ROS 2 stuff? Maybe it would seem to me almost like there's a standard in the industry or in the ROS world as to how it should be, and maybe I don't know what the standard is. So if the standard is always provide a bearing, then I'm not going to try to overrule the standard.
I think you need a bearing at least for the start and for the finish of your mission, right? And what happens inside here can be calculated, and if you don't want to define it, that's fine.
I've only ever heard of, in terms of navigation, I've only ever heard of them using pose, and pose by definition is a position and orientation. So the orientation, you could choose not to use it, I guess, or but the navigation is gonna try to fit the in pose, meaning a position and orientation.
Yeah, gotcha. Yeah, if that's a standard, I don't want to try to come up
and it's also true in nav 2. That hasn't changed.
Just as an example, before I started messing around with ROS, I had spend an inordinate amount of time messing around with Ardu rover and trying to get, I don't know, I first sort of forgotten some of the names. DIY drones comes to mind, I don't remember. But I mean, this is an example of a mission in their nomenclature. I mean, if you go to a piece of software that's open source called Mission Planner and you point and click on a map and you save the waypoints, I mean, this is ultimately the text file that you get. It's not very complicated. I mean, here's the heart of it, and that's, a lat long with, I think these were probably distances, I've forgotten. I mean, and so if we're not at that point, that's cool. I'm just trying to wrap my head around, step one, test what's the cross-track error running, a simple A/B line, and is the physical steering control reasonably precise? And then step two, once the steering is tuned and cross-track error is within some tolerable degree of measure, feed it 200 waypoints and go cut a hayfield. And whether that's lat long or whether it's, a reference to a central point, that's what I'm just trying to get my head around.
I think you'd have trouble with lat long, just from the sense that it's nonlinear, like depends on where you are in the world. If you're doing navigation based on lat long, I think that could be more challenging, especially over longer distances. If you have larger acreage, it's, I think, going to be more challenging. Can't really think of how that is right now, but usually I've seen, it depends on who you ask, but in UAV world, we called it Earth-centered, Earth-fixed. It's like an XYZ origin at the center of the planet, and that comes to the surface at a certain, so you can have a surface tangent kind of origin, but I don't know. I've never seen anybody try to navigate based on pure lat longs.
Those are waypoints you've recorded yourself, Al, right?
No.
No.
Those are, I went through a process of writing a program that took 4 corners of a field and wrote a Python program to create ever reducing waypoints, lat long
Sure.
points using what Jeremy was talking about. I went through painful learning exercise of
The projections.
yeah, I mean, calculating all of that stuff. I mean, it was torturous and fun all at the same time.
There should be a lot of libraries to handle, like, to do
There was one called NVector. It's fantastic. That would do all of that stuff with decimal-based lat long, and it would do the elliptical curve of the Earth, and supposedly the precision was super and great and fantastic. But
yeah, I tend to use those problems have been solved many times over, and like if you find a good library, that's probably the way to go. Try not to reinvent the wheel. That's the point of software, right? But
absolutely.
But I was going to say earlier when we're talking about position-based navigation and path-based, kind of alluding to difference there, and I think Matt can speak to this, but like for the most part at ASI, we're dealing with path-based navigation. You plan a path and the tractor tries to stay on that, following that, stay on calculating off path error, and then also staying on the heading of the path. So that was how we did it. And then, you know, you look at Ross, and Ross is more about a series of waypoints, and each waypoint can have a different orientation and position, of course, different position. Well, I guess you could have two waypoints on top of each other with different orientations. That's valid in Ross if you have a zero turn radius. In UAV land, we had waypoint navigation that was somewhat like path. I guess I wasn't as familiar with the planning back then, but it was, I mean, we had like a waypoint capture mode. If you got so close to the waypoint, it would capture it so it wouldn't circle back and try to fly that waypoint again. But because it's sometimes harder to, if you got some strong crosswind, you got some other things fighting you in the air, right? So, but anyway, rule of engineering. If it seems easy, you're doing it wrong.
That wasn't
just
for you,
since I
Jeremy. That
found
was
it-
for the whole conversation.
Yeah.
That wasn't specific
No,
to one person. So
I
don't take
completely
that.
agree.
I had to get this shirt. I just thought I saw it. I was like, that's perfect.
I think this brings up the point, and you know, like in Nav 2, I don't know if Matt, you had a chance to talk to Steve McKenzie
Steve?
yet.
Yeah.
Did you guys get a chance to talk? I know he wanted to.
Yeah. So they're on a GPS demo with the nav stack, with the
Oh.
Nav 2.
He's going to do that.
They're yeah. That's
Okay.
we're currently Vinny's working on that, and is trying to get a couple robots ready for that.
Okay. Cool.
One little thing about Vinny, you had like 3 dots, right? Instead of trying to feed the lat and long to move base, I think we need one more node. So you have 3 dots, and you have your robot over here at the edge of the field, let's say. And so what you do is you send your current position of your robot, the 3 dots that you want to travel to, and that goes to a path planner, like a Dubin's path planner generator. And what it will do is it will give you back your orientation. You have your orientation of your robot, right? You have your X, Y, and your where your robot is pointing. And you want your robot to go to this dot, and then you want your robot to go to the next dot. So the path planner has to say, okay, I'm gonna keep my heading straight, or I'm gonna take the next 2 dots and I'm gonna use that if you're trying to like generate the path.
Sure. My question is, wouldn't you, for that last point in your chain, wouldn't you want to define an orientation for there?
Not really, like if you
No?
had one
Okay.
point here and one point here, you just whatever that happened to be, you just continue on, and then that's your heading. I mean, so like your path planner is calculating that heading. If you only give it the XY, you have to have another intermediate node before you send that path into move base. My guess.
That does something even more global than the global planner.
Well, you're replacing the global planner.
Sure. Okay.
Yeah.
Interesting.
Or you're making your own global planner. And then for the area coverage, that's all done with a planner. So all you have is your robot, you have the polygon of the field, and then you have the area coverage. So you're not really entering any points. You're entering a shape,
Right.
a polygon shape.
That some node dissects into goals for each robot.
It doesn't.
Yeah,
I mean,
I'm
sorry.
Oh, I was just saying it's a little confusing because we're talking about three different types of planning and navigation for a robot. One is like dynamic planning. I'm in RViz. I'm going to send it a position orientation, and that robot's going to go there based on the map and all the other stuff. The second type that we're talking about is I have a specific breadcrumb path that I want to follow, and that is in GPS coordinates. I need to translate that into a nav path into ROS. And then the third type of navigation we're talking about is I've got this field shape and I want to cover the whole thing and my implement's 12 feet wide and I can, that type of thing. So I personally just try to do the very simple thing first and then second and then third. But
I think the very simple thing is this really the same for all of them. They just add more constraints as you step up. So like you said, the first one is just 2 poses, right? I'm here, I'm at pose A, and I want to go to pose B. There's no constraint on how to get there or what path to follow, right? I can get there in any way, and I can enter the goal orientation in any way. The second way is I need to follow a certain heading constraint. I don't want to, I want to kind of drive along that heading of these points that I'm, kind of like a Pac-Man path I'm gobbling up along the way, right? And the third way is here's an area that I need you to cover. I'm applying another constraint, which is, you need to make sure that you've driven this whole area in an optimized fashion such that you're not adding too much more driving to like when I have to turn around, I'm not doing a lot of extra work on the ends and that kind of thing. So I think of it as kind of the same thing. We're just kind of adding constraints as we move up in complexity, but your point's still valid. It's like, start with the easy one first, start with A to B, and then try paths, as it were.
Yeah, that's really good. Both Matt, your example, and Jeremy, your examples, those are good ways to kind of frame up. There's different use cases, and then how do I think about each different use case? That's good. I wanted to go, if we could go back to Matt, what you were saying to Vinny about you, and this is partly I don't understand it very well, but I've got a global planner and I've got a local planner. And then were you saying kind of off to the side, I would have something called a path planner? Is that what you were describing?
yeah, yes. And I don't know exactly what that looks like. With move-based flex, following a path, I just generally just send it a path. I don't use a global. So with move-based flex, you don't have to use a global planner. You can just interject and then a path, and then your local planner takes that path and then follows it. So that's the way that I did that part of it. And then so the global planner is nice. If you have cost maps, you have obstacles in your map. What that does is it will navigate you through and around things dynamically. So if your sensor happens to pick something up, or if you put another obstacle in your map, it's not like a hard path that it's going to follow exactly every single time. It's gonna calculate that out. We can use multiple global planners and things like that. That's a little bit adds more complexity.
Sure. When you mentioned cost map at a global planner level, I'm trying to think about, could I use Jeremy's example of a shape, or your example of a shape, and convert that into would you convert that into a cost map and then turn that into a global plan, or there's other ways to do it that are easier?
Well, I think to convert a shape, you're going to first have to break that into a path, which is going to be done outside
the global planner.
The global planner, local planner architecture. And then it'd be fed into that architecture either as a series of waypoints or as an exact path. And what Matt was talking about, bypass a global planner.
Cool.
The hard part is just simply clicking a point on RViz and sending your robot out on a mission. Now, to Al's point, if you want to do like an A/B line test, that becomes more difficult because you have to, click exactly on RViz, exactly where you clicked the last time. Like you want to and have it come back to you, and then you want to see, can it stop where I told it to stop, and then for your XY error, and then your yaw error. It takes a little while. So just by doing one point and then watching your robot drive, and once it's tuned, then you can try to say, okay, now I want to follow a path and multiple things. I don't know if that's making sense with that, or what's the best way to show that.
I'm still trying to get Gazebo to do the exact same thing that RViz does, doing what you said. I want to start here, go here, and then come back and see if I can get, because I'm telling where to go in RViz, and I've got Gazebo over here doing the exact same thing in theory. Because there's, in the simulation world, there's going to be some slippage and stuff like that, right? So it doesn't have to come back exactly to the same point. But I get what you're saying. Then the next step would be to take that to the real world and say, can I achieve the same thing that I think I'm achieving in RViz with my real device?
Yep. And if you even want to, like a simpler example, use the lawn tractor simulator that runs on stage, and it's way less complicated, not as accurate. So like stage, Gazebo, real world. That's layers of complexity.
Gotcha.
So
go from stage to real world.
You skipped Gazebo. So Al, to answer your thing, we're not there yet to where we can do the planning of waypoints. I thought I would be, but we're not there.
Well, I mean, I was just trying to put out there sort of what my thinking was and where I was at, and if we're not there, I understand. I mean, holy cow, we're all doing this on our off time, right? So.
But yeah, if you do want to test out something this weekend, I think it still would be useful to see how well your local planner is tuned if you just feed it something through RViz.
Yeah, you say that like I know how to create a map in RViz for my coordinates. So my suspicion is there's some magic to that I haven't learned yet, but I guess I'll figure that out.
If you have your move, and from what I understand, you do have move base set up. What you're sending in RViz is a goal pose. So it's not GPS. It's you see a model of your robot on the map, and you send it a pose relative to that, and it will navigate to that.
But in RViz, so I have not. I'm going to use the term localized my RViz simulator to be my physical coordinates. So in RViz, there's in the ROSAG simulator, there is that block in the middle of the map, right? I don't know physically how big, how many yards or how many meters left and right is that map. That block is not in my backyard. So what I'm trying to say in a very clumsy way is,
you need to get that block out of there.
Well, that map doesn't model my backyard, and I don't know how to do that.
I would say give it a command that is just a hair forward, and you can. I guess your question is, or your problem is, you don't know what resolution we're at.
Well, I mean that's a crisp way of saying one of my issues. Yeah, I mean I mean, so that universe that's in the simulator, what's the dimension of that universe?
Okay.
Anybody know? Is that
It's defined
100 by
somewhere, and I
100
can point
feet?
to it.
I'm sorry?
That's
It-
your
it is
field
defined.
down in Texas. It is defined. 0, 0 is one corner, and then you can go up and those are in meters. So you go up and see where the other corner is, and the other corner, and the other corner.
But how big?
Okay, this is another little weird thing with navigation. Like, you need a map, but you can have a blank map. A blank map is just white square, and there's no obstacles, no fences. You just load a blank map and then you can drive around. But you have to watch and make sure that you're not running into fences and trees and things like that.
So the map in the simulator is what you're calling a blank map.
No, that one actually has a border. So Sam made that map of your field down in Texas, and it has a black border on it. And that black border, the navigation won't, that shows up in the cost map as an obstacle. And so it won't drive into that.
If he would have used the GPS coordinates I gave him, whatever, how long ago that was, I mean, we're talking about a 300 by 300 meter field, more than likely.
Yeah.
With a block in the middle.
Yeah, but for testing, very simple. All you need is it's just a blank map. Load up a blank map and drive around. And your 0, 0 is wherever your robot wakes up. So it's like relative, you know. If you take you can look through the class on construct, and he shows you how to make a map. So you can drive the boundary of a field with your GPS, and you can build a map. But just start out, just use a blank map and drive around your backyard. Or you can even use the lawn tractor simulator. It doesn't matter. The lawn tractor simulator isn't GPS coordinates. So wherever your robot wakes up, it'll be in that position. It'll be 0, 0 where your robot wakes up on that actual map in the simulator. And then you can drive around and then you can see your robot. Now, the shape of your field in Texas is probably a lot larger than what you're driving in now. So you have to be mindful of that.
So is it this value right here, the height and width?
So
Am I in the right?
So what I was talking about, where it's defined is, and I don't know if it will be in, there's something called map. It might be in the sim folder. And then go to, yeah. And then that YAML. And then I guess the PNG, that Ross_farm_v1 is
Al's field.
That's Al's field.
with
Yeah,
that resolution that maps, I guess, is it pixels to meters?
Yep.
Okay.
It does look like there's just a field.png that's just a square one that you could use.
There,
Yeah, that's just a generic. It does have a boundary, the black line.
there's a grid. I don't know if is that 1 meter then? 200 by 200.
And then defined by whatever resolution is set in that YAML. So you'll have to, if you want to use the fields, then you'll have to change the image to fields.png.
Right here.
Or just be careful, right?
Yeah, just make sure you stay in the middle here somewhere.
That's a much easier approach for me than trying to muck with the YAML file.
Was the PNG file, is that like the the texture of the map. By that I mean if you put in RViz, that'll be what the ground looks like.
Right.
So if you took like a satellite image of your field, the actual field, and replace the field PNG with that, in RViz, should like show the satellite image as the floor of your.
But I think this PNG has semantic meaning, whereas if you put a satellite image, it might not. I think this PNG is really just a representation of your cost map, whereas the darker areas are, quote unquote obstacles, and the lighter areas are free space. But if you feed it a satellite image,
Okay.
unless you manually grayscale it, you'd have to play with it to make it semantically work with the map server, is my understanding.
More like okay. When you if you're working in 3D and you have the grayscale image of like a mountain range, where lighter stuff is the mountain peaks and the blacks are the valleys, not everything, but instead of that being obstacles, I assume somehow. Instead of just a picture texture.
There are ways to put normal images into RViz if that's something you're interested in. There's also a tool called navpath that you can use to visualize against like a Google Maps kind of service that's outside of RViz.
Yeah.
Hey, look at that field. I think you're on mute, Al.
Yeah, I think he tried to simulate that corral. So look at that. There's an A/B test going on there. I can't believe Google hasn't updated their map since that was going on.
There's a lot there.
Well, for me, it's just a simple matter of trying it out with the 2D nav goal and being extra cautious for the first few tries.
And you made sure your e-stop is doing what you think it is, right?
I test my radio frequency e-stop every time I go out. Yes.
Okay. So as long as that's working, well, what's the harm?
It's not low ray, but or low ra, however you say that, but it's close enough, or it gives me enough coverage to keep me from driving into the neighbor's pool.
So Al, let me think about this. You're going to take your tractor outside, park it somewhere. Are you going to record its position somehow, or are you going to sit down and type its current position into something? And then,
Well,
yeah.
I think what I heard Matt say is whenever I bring it up, that's going to be position 00. So I'm going to get it out into the yard, probably close to the middle. Bring up this, do the Ross launch commands, and then in a very tight space, start giving it 2D nav goals and
See what happens.
Stand back and make sure the battery is good on the e-stop.
Oh, that's good. It's good to talk through it because I'm still thinking how I'm going to do that on my stuff too. So, but that's good to hear it. See, what I was going to do is I was going to do similar thing, right? Get it someplace where I'm going to start, and then I was going to manually drive it. And this is part of my conversion issues. I'm still converting from Java over fully to ROS, but I was going to drive it in Java manually, tell it where to go. I want to go down this path, and then I want to turn, and then I want to come back, and then I want to, get back to my starting point. And I was going to turn on the GPS recording while I was driving. Then when I get that all done, then I'm going to take that file, have a whole bunch of waypoints, and move it over to ROS. That's the way I was going to try to go through it, and then see if I would drive the same thing again.
I would do that. I
kind
just
of a
don't.
Playback.
Yeah, I'm not educated enough to know how to reuse a playback, or is there a playback feature?
So
Where's
the
playback feature?
the bag you sent on the Slack, that's you can actually play that back.
I know how to play back a ROS bag file, but I don't know how do I feed that into 2D nav goals?
As in convert your ROS bag into goals.
Pull your GPS coordinates out of the ROS bag, right?
Your odometry has X, Y, and yaw.
And you guys may have answered, and I just wasn't listening close enough. So, right, the bag file's got all of that actual location data.
Yeah.
How do you feed that into?
So would you echo the topic, echo the ODOM topic, and put it into a text file? Is that what you're saying, Matt?
Odometry is a pose and a twist message. It's two messages combined. That's odometry. MoveBase wants pose. So what you could do is, like Allan was saying, you just play that ROS bag, echo the pose channel, put all of those poses in an array, and that's a nav path. So a ROS path is an array of poses. I wish there was like one little easy button that you could push and then do it, but like.
But no, finish that train of thought though.
I think that's a good way.
You echo that topic and save that data. So you've got that data. Then what do you do with that data?
So you take the pose data from your odometry message and you create an array of poses, which is a nav path. And MoveBase Flex will listen to a nav path. You just send it a full nav path, just an array of poses. You give it to MoveBase Flex, and away your robot goes.
And so you're going to publish that data on what? So you've
now
extracted that data out, and now you want to play it back. You're going to publish that to a topic.
A little bit different. It's an action server. So
okay.
you're going to convert your odometry into a nav path. And then you're going to take that nav path and then you're going to send it to an action server. MoveBase Flex runs off of an action server. And it needs to have a nav path. So you send that action server that path that you just built, and then it will drive it.
And what does that code look like?
A monster, like all of it, but very easy. Al, if you would take a look at all of the ROS code that you've written the last few months and then go back about a couple of years, it's pretty impressive.
But where do I find the format of this action server and the format of the statement that it wants?
So I can share, I have the execute path action for MoveBase Flex written out in my behavior tree. So when you get to that point, I've done it before.
Okay, cool. I've been through the torture of you know, translating GPS points into something that Ardu rover would ingest. I could
Actually,
probably.
I've done it in both Python and C++. So
Python seems a little bit more forgiving for me. So I think I like interpreted language better than compiled. Allan, thanks for going down that path, man. No pun intended.
Oh man. Well, if in a week or two or three or whatever, I'll be trying to figure the same thing out again, and I'll have forgotten all this by then. So, so one question, Matt, on the nav path, right? So you've got this nav path. This is an array of poses, right? So far, so good. Hey, that's good. Okay, an array of poses, and I've got it in a CSV file, or
Yeah,
what do I say?
yeah.
What format do I save it into?
Yeah, text. Yeah, text file.
A text file.
And then,
Okay.
yeah.
you'll have to write an interpreter to get that text file or that CSV file into publishing. And that'll have to be an input to whatever you're sending your move base flex.
Well, that was where I was going to go next. I've got this thing saved as a text file, this nav path saved as a text file. Then I start up Ross. Al's got his rover out, or his tractor out in the middle of the field in a 0-0 position, and he's started up his Ross code to drive the tractor. Then does he have to start another? He has another launch file that he kicks off that will, I think he called it an interpreter. So we would then go open up that text file and read in the data from the text file. This is a new Python file, right? And it's going to read in that text file into memory. And then what is it going to, it's an action server. So we're not going to publish to a topic. So help me out with that. So once it gets read into memory in Python, what's it going to do?
You're going to send it using the execute path action in move base flex, and you send it as a goal to the execute path action in move base flex.
Got it. That's enough. At least I can go look it up and search on it and read some more on it.
And there's an example in my behavior tree stuff that's on the lawn tractor sim dev branch, which was just something I wanted to bring up real fast. I know we're running out of time, but I do want to create like a new repo on the main raw sag page, but with your rover, Allan, and with a Docker that we keep live, and then eventually the tractor with a real Ackerman URDF. Is that okay with, or is that going to be more confusing and I should just keep everything separate?
So I missed like a half a sentence there. I thought you were going to put it on the Ross tractor. I was just going out here to GitHub to look to see, but you said you wanted to keep it under my directory, or?
No, I said I wanted to keep it in the main, the Ross agriculture.
Oh yeah. Okay, sure. That sounds good. Sounds good to me anyway. Yeah.
Okay. Or is that just muddying the waters? I'm creating too many repositories and it's going to be too much for someone new to the group to figure out which one's which.
Well, like ideally it would be kind of cool to have like one move base set up with different robots. So we'll have an Ackerman robot, maybe a differential robot, maybe, is that what you were saying? We wrap all that up?
Yeah.
Or we create, I see. All the configuration files will be different for each one of those robots.
Right.
So are you saying you'd put it underneath here as a new branch?
So yeah, if you go to Oh,
Or go
it's
up.
not develop. It's 13. If you wait, sorry. What's your question, Alan?
Oh, I was just gonna have a visual to go along with what you were saying as to where you wanted to put it. So here's Ross Ag.
Oh yeah, I would create a new repository that's like
Oh, okay.
Ross Ag mobile base. I don't know what the name is, but let's say it's mobile base for now. Where you know it's a common architecture, and then you just plug in which robot you want to use it for. And ideally, this will go to my goal of making our simulation architecture closer to our actual the hardware implementation that like Matt and Allan have. Because right now it seems like there is a disconnect between our simulation architecture and our hardware architecture.
This is way over my pay scale. This sounds like a Matt question.
I agree, Vinny.
I've
just
never
nod
heard
and
of the
agree.
simulator not matching exactly the physical world.
Oh, oh.
Gonna take some work, but you know, I'll chip away at it.
Well, yeah, I don't. It sounds good to me. I don't have any expertise to know one way or the other, Vinny. So sorry. If you can get that done for Al this weekend, it'd be great.
No, don't rush because I'm very slow. Besides that, I've got a 3D thing to do for
Look at that. Al, what do you think of these boxes? Unicell box. This one won't fit.
I don't see your video for some reason, Matt. What am I doing wrong?
Alan, if you stop sharing your screen, I think it might make
Oh,
it
that might
easier.
help.
Yep. These servos are pretty nice, but they're pretty exposed. I think Kyle was saying that he just sprays this with polyurethane conformal coating. So you unplug this, spray that with conformal coating. There are a couple of pots that maybe you want to put some rubber sealant over before you spray it, but it doesn't have a case. The other ones that we bought had a case, so if it got water on it, it would be okay.
Yeah, I mean, I was just going to do a box, you know, a box that came down and covered it like his. I just didn't. I'm not a big fan of doing it all in one go. So I would probably, like you can see, this is 5 millimeters thick. And so the case probably only needs to be 2 or 3 millimeters thick. And I would have probably, like the case would go, how do I do this with the camera? Case would go here, maybe put 4 screws, 1, 2, 3, 4 there. So you screwed the case, the cover on. That's what I was thinking.
I like it.
But Matt, this is plastic, man. I mean, this is not going to take 100 pounds of pressure, right? Plastic.
Yeah, it's a good point.
Well,
Probably
it depends
mounting
on what
off
your
of the
infill
metal.
is, right?
Yeah.
Well, yeah, I mean, you could do that.
Lucky, make it 5 millimeters or 8 millimeters, and then it'll work.
But so it's whatever you want. I mean, because if somebody was being a little clunky here, because you could take a 1-inch strip of metal and cut this out, get somebody to weld that.
What
and
is
then
at that
3D
interface?
3D print the cover.
Sure. What is? I mean, I'm seeing this kind of T shape. Is it filleted there, or is it a sharp? I can't.
I did not put a fillet in there. I could, but I just didn't because I was just trying to get I wanted to get these holes aligned before I went.
Oh,
any
okay. That
further.
wasn't your goal. Okay, I understand.
I 3D print like I code, very slow. It's one step at a time.
It's pretty cool. Um,
So
anything
you
else
want-
for tonight?
You want to keep working on this?
Oh. Yes, I think we may have to because they're only selling these without the case. So either we buy like a Unicell case or manufacture something.
Can you put that back up there?
Yep. This is just a case you can get off of Amazon. They're like $10. But they're
Sounds like
Oh,
your
this
piggy
mounts?
bank.
yeah, a couple pennies. It won't fit, but they have these in different sizes. But
Did you say that they were putting like epoxy over that, or what? What was the?
Formal coating?
Oh, okay.
It's called conformal coating.
Because we did some, I did some work one time, and we had an embedded board that they would pot. They would put it basically in epoxy mold, and that's pretty robust.
Yeah, you don't
How
get.
about
to
how
change
insulative
anything.
is that on the heat sink?
I didn't hear that.
How good is that on the heat sink? Is it insulated too much, or is it okay? Or
Oh, yeah, it wouldn't be good for a heat sink, but this application didn't have a heat sink, so I was just thinking about the. I mean, I guess in that situation you could pot just the
Okay.
board itself and expose the heat
well,
sink.
I mean, you know,
I've seen ESCs that are just kind of dipped in epoxy and you have the heatsink just exposed like that. I've seen it.
We call that plasti dip.
Well, how much torque are you going to put on this thing, Matt? What's the application?
40 kilograms.
80 pounds?
It'll do 180.
Yeah, I'm not sure even PETG with 100% fill is going to hold 100 pounds, but
Yeah,
we
the
can print
ones
her
that
up.
the servos we used to buy had a metal mounting. I mean, it was really strong.
That would be better than plastic.
So Matt, you're saying that little thing you just held up would deliver 180 pounds of force?
This thing will buck your bales for you, Alan. You got spare bales?
Yeah.
There
No
you go.
way.
Why
does
not?
that
It's 40
It doesn't
pound,
look that
50
strong.
pound bale.
it's 180
Ooh.
kilogram or what? What's the
They're impressive.
I guess. Wow.
what's the length though on that rating?
I didn't hear that. The reading?
Is that kilograms per centimeter?
Yes. Yeah. May be able to see that, but it's 180 kilograms per centimeter. They're pretty stout.
I'm not questioning that. I'm just,
Sorry for.
the actual cover, I had no problem with that being plastic, but the structural piece, I think you're going to be more happy with. I mean, we do the design so you can take it to a fabricator and say, make this out of metal. We can try it and see how much it will withstand, but 80 pounds, that's a lot of torque. I mean, I would just be worried about, like there's going to be a stress point where it's connecting.
Yeah.
180 kilograms per centimeter of arm length from the servo. So the farther how many centimeters out from the turn radius on the servo is going to affect how strong it is. But it's still really strong servo.
Yeah. You can buy them up to 500. But we're running long here. Is there anything else for tonight's meeting? Really
But
great
you want to use
discussion.
it for the transmission.
Oh, we can talk about this in Slack.
Okay.
But, thanks for being here. Great discussion, Alan, Al, Benny. Thanks for going over that. That's going to be a little bit of confusing, but I think we can get there.
It's good to talk through it. It really helps.
Thank
All right,
you,
good night,
everyone.
everyone.
Thanks, everybody. Good stuff.
Good night.